Good evening and welcome back to the Turdford channel. All right, so today what y'all are supposed to be learning, well, you're actually learning because I'm down the hall in some kind of meeting right now. But anyway, I'm sure this will be just as good as me in real life. So you're supposed to be doing a lab today. Well, obviously you're not doing a lab right now. So instead, what I want to talk about today is two things. I want to talk about volume, obviously, and I want to talk about density and a little bit about what these things are at this point. So when we talk about volume, how much space an object takes up, you've done volume plenty of times before. Volume is nothing but, and for most cases, y'all are, 10th grade, length times width times height. So if I wanted to find the volume of this cube, how much space it takes up, all I've got to do, well, like in this one, it'd be 10 times 10 times 10. So the volume of this cube would be 1,000 centimeters. And now check it out. You've got a centimeter times a centimeter times a centimeter. Well, I don't know if you know from math, but this is the same as x times x times x, which means we've got a centimeter cube for a unit. So we got a little bit of an idea what's going on. Now, what about like this smaller cube down here? So down here, you'd have a volume of 1 times 1 centimeter times 1 centimeter, which that's actually 1 centimeter cube. Now, odd thing is, you've heard of this word milliliters before. Neat thing is, a centimeter cubed is actually, that's what a milliliter is. So if you could have a box that was 1 centimeter by 1 centimeter by 1 centimeter, that box would hold exactly 1 milliliter of liquid. So anyway, this kind of gets you a little bit into what we're doing here. Now, there's several different ways we can find volume. Most of what you're going to be doing a la 10th grade is just this. Length times width times height. And there's nothing new there. Oh yeah, if you give us a sphere, I can find the volume of a sphere. I can find the volume of a cylinder. I just got to plug in. Matter of fact, the chemistry class, the lab that they just did this past week, in their lab, they had to find the volumes and densities of all three of these. Now, let's get into what density is a little bit. Mass per unit volume. Oh, I love a good textbook definition. Now, some classes might use this D equals M over V. I'll go ahead and tell you, I'm preparing you for physics and chemistry. Physics and chemistry, now, it might be kind of hard to see what this is saying, but it's actually the letter rho. It's a Greek letter rho, which if you really look, the Greek letter rho really just looks like a lowercase p with a slanted tail on there. So if we're going back to elementary school here, doing a little bit of writing, that's all a rho is. So you should have kind of an idea of what we're getting here. So let's get into a little bit more what density is. Well, halfway you should already be a little familiar with density. You know that, say you had a huge block of styrofoam. Huge block of styrofoam. Styrofoam. What would you know about that huge piece of styrofoam? Well, you know that it's going to be pretty light. Is that how you spell light? Yeah, I think so. So it's going to be light in terms, you know it's not going to weigh very much at all. Why is styrofoam so light? Well, it's because the particles inside of it are not packed together. You've got a lot of air inside there. So the particles are not very compacted. The funniest thing I've always thought about in like movies is when you see the old pirate. Arg. I wonder if I could draw a pirate. Ah, I am Captain Jack. This is a horrible looking pirate. What if I can do? I think I've drawn the cowboy, not the pirate. Hold on, let's give him some hair. Har! Give him a big old earring. Ah! This is not a pirate. Wait a minute, let give him a sword. I can save this. Now he's a pirate. I always love watching the old pirate movies and how you'll have this pirate and he's got his sack full of gold, and gold's not green, but hey, I only got 4 colors I can write with. So he's got his whole sack full of gold and he's driving across. Gold is incredibly dense. Incredibly dense. Which means if you had a block of gold, just a very small chunk of gold, it would weigh, oh, good grief, I wonder what it would weigh. Now I'm actually curious. I wonder if it's possible that I could pop up an internet window. No, I ain't going to do it right now. obviously it would weigh a tremendous amount. Wait a second. I know physics. I can actually figure this out. What if I had a block of gold? How big of a block of gold? Let's just go with this. Let's go with 5 centimeters by 5 centimeters, so a small cube of gold. 5 centimeters on every single side. Well, that's nothing but 5 cubed. So 5 cubed, 5 times 5 times 5 is 125 centimeters cubed. Well, that's interesting. So if I had a piece of gold, 125 centimeters cubed, and then I need to know something, the density of gold. And AU is the symbol for gold. It's one of my favorite jokes. A gold atom walks into a bar room. Bartender goes, AU. Are jokes really as fun on video as they are in real life? Anyway, I don't know. The density of gold is 19.3 grams per centimeter cube. Gold is incredibly dense. It's very heavy. Water has a density of 1. So that means gold is 19 times heavier than water, which is why gold would sink in water for that matter. But anyway, the formula is density equals mass over volume. Now, all I've got to do is write 19.3 equals mass over 125. Now, what I'd like to know from y'all mathematically is, how do I finish this? Well, what's the opposite of dividing by 125? That's all algebra is opposites. The opposite of dividing by 125 would be multiplying both sides by 125. So 125 times 19.3 means that would be 2,412.5 grams of gold. So that'd be my mass. I'm just curious. I'm going to do a conversion to pounds, which y'all are supposed to be able to do. 0.412 times, see if I can finish this out, times 2.2, can't do any math right now, 5 pounds. Now that's interesting. That means if you had, and that's not very big, 5 centimeters, 5 centimeters by 5 centimeters is only like this big. Well, except you're looking on a screen, so it's huge possibly. But that small piece of gold would weigh 5 pounds, which means if we go back to Captain Jack over here and he's toting a whole sack of gold, he's got to be Captain Awesome Jack. He's going to be ripped. Wow, those are not muscles at all. This video is terrible. But then again, I'm having to draw it in a hurry. He would have to be Uncle Captain Rippin'. I just drew boobs on Captain Jack. Hold on. Pardon me. Let's see if we can. Now I just. Forget the pirate. What about the sack? This sack would have to be made of some sort of super duper Kevlar amazing fabric that's the world's never. In other words, it's ridiculous when you see like these old pirate movies with a guy toting a sack of gold around. So anyway, let's see if we can actually get back to this lesson over here because my artwork is horrible. So let's get into here. So where are we at? So I've given you a few little densities. Now here's a little random tidbit. Pop little common fact here. How come ice? Here's water. Water has a density we usually just say of 1. Okay, maybe technically 997, but we usually just say 1. It's a whole lot easier to say. But look at ice. Ice is 0.917. Why does ice, if ice is made of water, then why does ice have less density? Well, you got to remember something. What happens to water when it freezes? If you've got water, when it freezes, what happens? That's right, it expands. And so if that water expands, little common thing here, if the volume goes up, then the density goes down, is what's actually going to happen in this case. So let's kind of get into doing some calculations here. I'm going to see what we can do. So how would we, and this is what y'all are supposed to be doing in the lab right now. How do you find some of this type of stuff? Well, let's say you're reading a problem, and this problem tells you that you've got a block. And we've really just done an example. So let's say you go to the lab, and you've got a wood block. I got a great idea. Hey, has anybody back there measured anything? Mass, length, width, and height? Come here, Lacey. You're about to be on TV. Actually, you're not going to be on TV. We can't even see you. Bring me your numbers. Hurry, quick. Right now, we're just waiting, and I'm tapping a screen because you're not here. All right, so Miss Lacey Smith is handing me, a block of pine. This is fascinating. And according to Lacey, say hi, Lacey. She don't sound real enthusiastic. Say hi, Will. I like this kid. Now, according to Lacey, she's measured this block of pine, and it is 7.83 centimeters one way, 1.92 centimeters by 2.55 centimeters. Now, my drawing doesn't look so great. Oops, I just dropped my calculator. But let's see. So they've measured the length, the width, and the height of this. Well, all right, that's awesome. And according to Will, he's also put it on the balance. You know what the balance is, a little thing that does this, and there's little weights over here, and they're like, doo, 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 doo. So according to Will, after setting this block on the balance, how much does it weigh, Will?
18.50 grams.
Oh, that's fascinating. So according to Will, it has a mass of 18.50 grams. Hey, y'all want to see what your density is? Come on around here, guys. This will be great. I dropped my calculator again, and I'm screaming in the camera. And this is going to be very loud. So, how do we find the density of that block? Well, it's easy. If I want to find the density, I'm going to first write down the equation. Mass divided by volume. The good thing is, Will's already gave me mass. It's 18.5. And check it out. Lacey gave me length, width, height. So all I've got to do is come over here. Volume is equal to length times width times height. This is probably where Will's going to punch this in the calculator for me because he's just standing there. 7.83, or Lacey, I'm not really that picky, times 1.92 times 2.55. Oh, I can't wait. What do we get?
8,655.295.
Okay, I'm pretty sure Will has messed this up. There's no way this is 8,000 and something. That's huge. You'd be saying this block is the size of my desk in the back of the room. Ah, now we've got a professional. Lacey's on the job. So now we'll be waiting. Oh my goodness, it's a calculator. Length times width times height. It's a good thing y'all can't actually see what's going on right now. It's a shameful sight.
38.335.
So 38, and I'm going to round off the three figures. 38.3. So that would be centimeters cubed. So Lacey's giving me this. Now, I believe the 38.3. So now I've got volume. So if I want to find density, density is nothing but mass, which is 18.5. So all I do is replace M with 18.5. And now I'm going to replace the V with Lacey's 38.3. And now Lacey should be able to tell me what she's about to do. What are you doing right now? I see you punching numbers. And Lacey just said that she is dividing and
0.48302.
48. I'm going to round to 3 sig figs, 0.483. And let's see, that would be a gram per centimeter cube because I took grams and divided by centimeters cube. Congratulations, it's a boy. Y'all have done a great job today. So thank you so very much. If you'd done a rod, we'd do one of the rods, but y'all hadn't done one of the rods. So there, that's how easy it is to find the density of something. All I need for you to do is to get length, width, height. Why? That gets you volume. Once you've got volume, all you need to do is plug that volume in, get your mass, and you've got your density at that point. Wow, this is actually really easy, Mr. Cully. I know, it's great, ain't it? So let's go back and try something else. Let's see how y'all are doing. Let's go back to your notes. I'll get there eventually. How long is this video? 14 minutes. You can never have enough turd ferg in your life. This is what y'all are going to be seeing, though, in your homework. You're going to be seeing the written problems like we just did, but you're also going to be looking at this one. What volume? This is what y'all are going to be doing the most of this year, and it's not hard. Matter of fact, you don't even have to read the problem to do it. Look at what I'm doing. I'm going through the problem. I'm just underlining some things right here. Well, I kind of got a little idea about something. Here's what my idea is. I'm going, go, go, go. You see, I know that anything density is going to finish with this unit. I know that anything mass is going to finish in grams. And I know that anything volume is going to finish in centimeters cubed. So based on knowing this, I don't even have to read the problems. Watch this. I'm going to go back to this problem again. I'm not reading it. This number says 1,500 grams. That means that that has got to be a mass. Now, come over here. 21.5 grams per centimeter cubed. What has that got to be? That's a density. And then it asks me to find volume. All right, well, I can do this. So that's density and volume. I'm going to write down my equation. Density is equal to mass over volume. Hey, I'm halfway there. Now, substitute. Put these numbers in. So in place of density, I've got 21.5 equals mass, which is 1,500. And this is going to be where some of y'all shut down. How do you do this math? Well, let's make it simpler looking. What if the problem was 2 equals 8 over x? How do you do the math on that? Well, you got to get this x where it's no longer down here in this denominator. So the opposite of dividing by x is to times by x, which looks weird to write times by x. But anyway, you times both sides by x, and you get 2x equals 8. That means x is equal to, looking around the room, Will, what's 8 divided by 2? Will's a good boy, 4. So, anyway, so now we're going to do the same thing math-wise here. The opposite, that's what's going on here is we're dividing by this v. If I want to find what v is, it can't stay there. So the opposite of dividing by v would be to multiply both sides by v. So I'm going to multiply that side by v, and I'm going to multiply this side by v. Well, my v's cancel, and I end up with 21.5 v equals 1,500. Now, to get rid of the 21.5, I divide both sides by 21.5. And I don't have any of my sidekicks here to do this anymore, so I'll have to do this. And you need to be doing it too. 1,500 divided by 21.5 is equal to, do you have an answer? Do you have an answer? It's a good thing Jared Edwards ain't here. He'd be laughing right now. 69 point, looks like 7 grams. That's not a gram. It's a centimeter cube. Now, if I'm doing sig figs on this, I just blew my bonus because this has 3 and that has 2. So my answer should really just be, 70. I'm going to put a little decimal there and make that 0 count, centimeters cubed. If you want to make it really sexy, 7.0 times 10 to the 2. But anyway, I'm just getting carried away showing off now. Y'all, what you need to do, and I know this is a quick video and it's a lot to learn, but you've got those problems to try and go through. Go through the problems. Look for density, look for mass, look for volume. That should be your goal. That's not a V, that's an M. Get away. Look for volume. If you see a problem now, it gives you length, width, and height. It's doing that just so that you can find volume. That's it. Your main goal is filling in these things. Once you have them, go to your equation. Density is mass over volume, and fill it in. If you were working this problem and you found that density is 2 and mass, or let's say that volume is 10, then you'd go back to your equation and just replace, substitute those numbers. 2 equals mass is mass over 10. And you do your algebra. What's the opposite of dividing by 10? times both sides by 10. So 20 is your answer. That's easy enough. So what else kind of problem could you have? Well, you might have a problem where they told you that mass is 20 and density is 10. Find volume. Well, go to your formula. That'd be 10 equals 20 over V. Nuggets. I got V down here on this bottom. How do I get rid of it? Easy. Times both sides by V to get it off that bottom. And now look at what I got. 10V equals 20. Divide both sides by 10. My volume is 2. And that's all I have to do. Now, you are advanced class. So what might I do to make something tricky? Easy. When you're working that problem, instead of giving you everything in centimeters, I might try and sneak in like an inch in there. Well, if I do that, convert it to centimeters. That's my only trick. What else might I do? You're in advanced class. Well, I might give you your mass in like in 1.2 kilograms. Ha ha ha. Which means you have to know there's 1,000 grams in a kilogram. So your answer is, so that's going to be your mass. That's about the only things I'll do to try and trick you up. So anyway, that's the goal. So start going through those homework problems. And as you go through them and you try and read them, a block has a mass of 25.0 grams and a density of 2.7 grams per centimeter cube. What is its volume? Just read the problems. Go through. If you see 25 grams, that's a mass. If you see 2.7 grams per centimeter cube, that's a density. And then it says, find volume. Write down your equation. Mass, volume. Substitute. What goes in place of rho? If you're trying to spell that, it's R-H-O is how you say it. What goes in the place of rho? Well, in place of rho, we write 2.7. 25 over V. Oh, wait. How do you get rid of the V off the bottom? The opposite of dividing by V. Multiply both sides by V. 2.7 V. Y'all, this is as hard as the math ever gets this year. It's not that big a deal. Divide both sides by 2.7. 9 point, I'm going to round it to 9.3 centimeters cubed. I'm going to put my box around it. I'm a good boy. That's the way I party. Okay, I guess I should finish the box. All right. Well, in this case, I'm actually going to leave you with a great big old bye. Bye. Will, come here. Quick. 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 No, just come here. Quick. 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 Here. Will, now it's your turn. Say bye. Yeah.
Bye.
Here's the pin.
Okay.
Say bye. I said bye.
Okay.
So here's Will. Hey, you write just as bad as me. Bye. Bye. Fast enough. Hit that button that says stop.